we'll cover Module 3, that is Polymers and Powder Metallurgy. Introduction. Polymers are macromolecules built up by the linking together of large number of much smaller molecules. The small molecules that combine with each other to form polymer molecules are termed monomers, and the reactions by which they combine are termed polymerization. There may be hundreds, thousands, or 10,000s of, or even more monomers molecules linked together in a polymer molecule. Polyamides, being a solid material, polyamide powder has the attractive feature of being self-supporting for the generated product sections. This makes the support structures redundant. Polyamides allow the production of fully functional prototypes or end-use parts with high mechanical and thermal resistance. Polyamide parts have excellent long-term stability and are resistant against most chemicals. They can be made overweight by impregnation. By polyamides, the polyamides materials used by metallized is certified as biocompatible and food safe under certain conditions. Polyamides account for the vast majority of 3D prints made on SLS systems. Selective laser sintering, SLS means selective laser sintering systems. Relatively new to the desktop materials, extrusion polyamide is a tough, durable material that can obtain medical certifications in desktop. 3D printing moistures make a material that is difficult to print and also to keep. In closed SLS systems, this is not a problem, but incorrect storage will degrade powder. Polyamide makes a wide range of products and is familiar to many manufacturers. Polyamide is a flexible and this enables many more parts to be made with it. Hinges, snaps, fits, parts and housings are the good fit for this material. Glass fitted or glass filled, aluminum filled and carbon filled grades extended the scope of material. Polyamides are macromolecules that obtain recurring amide groups. Phenol formaldehyde resins. Phenol formaldehyde resins are also called as phenolic resins, or synthetic polymers obtained by the reaction of phenol and substituted phenol with the formaldehyde, used as the basis for bakelite. They have been widely used for the production of molded products, including billiard balls, laboratory countertops, and coatings and additives. Phenol formaldehyde resins, that is PFs, are condensation polymers and are obtained by considering phenol with formaldehyde in the presence of an acidic or alkaline catalyst. Now, polyesters. Polyesters is a category of polymers which contain ester functional groups in their main chain. Polyesters is currently defined as long chain polymers chemically composed of at least 85% by weight of an ester by dihydric alcohol and terpenthylic acid. The name polyester refers to the linkage of several monomers within the fibers. Now, the classification of polymers. You can see the polymer is broadly classified into the four main categories, that is based on the origin of source, based on structure, based on molecular forces, and based on the mode of polymerization. So accordingly, in case of the first group, that is based on origin of sources, natural polymers, semi-synthetic and synthetic polymers, these are the three sub-classifications. So In the second one, based on structure, linear polymers, branched chain polymers, cross-linked polymers. These are the other three subsections. In the third main classification, that is based on molecular forces. The subclassifications are elastomers, fibers, thermoplastics, and thermosetting polymers. The fourth one, that is based on the mode of polymerization, addition polymers, and condensation polymers. This is the classification of polymers. Now, about the basic concepts. Now, we'll study what is the functionality. The functionality of monomer is defined as the number of bonds that a monomer repeating unit forms in a polymer with the other monomers. Thus, in case of a functionality of F equal to 2A, a linear polymer is formed by polymerizing polymers with a functionality F is more than or equal to 5, lead to benching points, which can lead across linked polymers. From the average functionality of the used monomers, the reaching of the gel points can be calculated as function of the reaction progress. Side reactions may increase or decrease the functionality in polymers chemistry. A double bond possesses a functionality of 2, while in organic chemistry, the double bond is a function group and thus a functionality of use. Polydispersity. In organic chemistry, the polydispersity index (PDI) is a measure of the distribution of molecule mass in a given polymer sample. The PDI calculated is the weight average molecular weight divided by the polymers, the number of average molecular weight. It indicates the distribution of the individual molecular masses in a batch of polymers. The PDI has a value always greater than 1, but as the polymer chain approaches the uniform chain length, the PDI approaches unity. For some natural polymers, PDI is almost taken as unity. The molecular weight, that is MW, molecular weight is a measure of the sum of the atomic weight values of atoms in a molecule. Molecular weight is used in chemistry to determine stoichiometry in the chemical reactions and equations. It is calculated as the sum of the relative atomic masses of each constituent elements multiplied by the number of atoms that the element in the molecular formula. The last one, that is molecular weight distribution. The product of polymerization is a mixture of polymer molecules of different molecular weight. For theoretical and practical reasons, it is of the interest to discuss the distribution of molecular weights in a polymerization. Molecular weight distribution represents the frequency of the polymer lengths, the frequency of narrow or broad. The narrow distribution represents polymer of about the same length. The broad distribution represents polymers with varying lengths. Molecular weight distribution is controlled by the conditions during the polymerization. Molecular weight distributions can also be symmetrical or skewed. To provide a reasonable estimate of molecular weight, it is necessary to provide more than one average. To fully describe the molecular weight distribution, it is necessary to prepare a plot showing the weight fraction of the polymer chains which have a given molecular weight. Since most polymers are polydisperse, the 4 molecular weight averages are often used in conjunction with one another to define more thoroughly the nature of the molecular weight distribution, and can also provide the information about the molecular weight which is present in the greatest frequency in the sample. Molecular weight is weighted average which favors higher molecular weight molecules and appear on the high side of the molecular weight distribution. Thank you.